Hello and welcome to another video on derivatives. In this video, we're going to discuss about the derivatives of inverse trigonometric functions. So let's start by finding the derivative of y equals sine inverse x. So we are going to write this function as we have y equals sine inverse of x. Now let's rewrite this function. So this can be written as sine y equals x. And then if we differentiate this equation implicitly with respect to x, we are going to get the derivative of sine y with respect to x is cosine y dy over dx equals then derivative of x is 1. Now if we divide by cosine y on both sides, we get dy over dx equals 1 over cosine y. Now, how do we write cosine y in terms of x? So that's the next thing that we need to do here. So let's make a right triangle. It's easy to see from the right triangle. Sorry, that's not what I'm trying to do. So let's make a right triangle. Okay, so now let's say this angle is y. Now what we have here is sine y equals x, or we can write x over 1. So sine y equals x over 1 means sine is opposite over hypotenuse. So this is x and this is 1. So the hypotenuse is 1. Now the adjacent, so this is our angle. So the adjacent is hypotenuse is squared minus the opposite is squared under the root. So that means our the function that we want is cosine y. Now cosine y equals adjacent, which is the square root of 1 minus x squared, divided by hypotenuse, which is 1. Or simply, it is, okay, so dy over dx equals 1 over, now cosine y is 1 minus x squared, under that is square root. So that is the derivative of sine inverse function, okay? Now, similarly, we can find the derivative of rest of the inverse trig functions right here. So I've listed all of them here. So the derivative of sine inverse function is this one. Derivative of tangent inverse function is 1 over 1 plus x squared. Derivative of secant inverse function is right here. Derivative of cosine inverse function, cotangent inverse function, and cosecant inverse function. So now, next, we are going to use all of these formulas and we are going to do some examples. So the first one is find the derivative of cosine inverse function of x squared minus 1. So now here we have to use the chain rule and the inverse trig, the derivative of inverse trig functions that we just looked at, okay? So the first step here is, so what is the derivative of inverse cosine function? So it is 1 over, so it's negative 1 over square root of 1 minus x squared. But here instead of cosine inverse of x, we have x squared minus 1. So it is x squared minus 1 squared. And then using the chain rule, we need to find the derivative of this function, which is 2x. So now that becomes negative 2x over square root of, let's go ahead and expand this one. So we get 1 minus, so x squared minus 1, the quantity squared is x to the fourth minus 2x squared plus 1. And then if we open the parentheses, we get negative 2x over square root of, so 1 minus x to the fourth plus 2x squared minus 1. So 1 minus 1 is 0. So we get negative 2x over. Now, if we factor out x squared from the bottom, okay, we will get, so let's do this. So let's go ahead and factor out x squared. So let's put that as square root and then factor out x squared. If we do that, we get 2 minus x squared. So x squared times 2 is 2x squared times negative x squared is negative x to the fourth. So now if we pull that out of the square root, we get, okay, so negative 2x over x square root of 2 minus x squared. And then we can cancel out this x and this x. So the final answer is negative 2 over square root of 2 minus x squared. So that is the derivative of that given function. Now let's look at another example right here. So the derivative of sine of cosine inverse function x. Now we'll do the chain rule. So we'll start from here. The derivative of sine is cosine. So this equals cosine of inverse cosine of x times the derivative of inside function, or the derivative of cosine inverse function is negative 1 over square root of 1 minus x squared. And then we know that cosine of cosine inverse x is just x. Then times negative 1 is negative x over square root of 1 minus x squared. And that's our final answer. Let's look at more examples. Now the next example is we have evaluate f prime of 1 where f of x is x inverse tangent function of x squared. Now let's go ahead and find the derivative, and then we can evaluate the derivative at x equals 1. So we have f of x equals x times the tangent inverse function of x squared. Okay. Now f prime of x equals, now we need to find the derivative of this function where we have to use the product rule here because we have two different functions, x and the inverse tangent function. So x times, so the derivative of tangent inverse function is 1 over 1 plus x squared. So 1 over 1 plus, instead of x, we have x squared, and we have to square that. So it is x squared is squared times, by chain rule, the derivative of x squared is 2x. So we did first function derivative of second plus second function, which is the tangent inverse x squared, times derivative of first, which is just 1. Okay, so that implies f prime of x equals, so 2x times x, so which is 2x squared, over 1 plus x to the fourth plus the inverse tangent function of x squared. Now that's the derivative. We'll stop right there. And then our goal is to find f prime of 1. So that means f prime of 1 will replace x with 1. So we get 2 in the numerator. Then 1 plus 1 to the fourth is 1 plus 1, which is 2. Then the inverse tangent function of 1 is squared, which is 1. So 2 and 2 cancels out. Sorry, we have a plus sign here. So 2 and 2 cancels out. So that means we have 1 plus the inverse tangent of 1 is pi over 4. Or finally, we can write this as f prime of 1 equals 4 plus pi over 4. Now, you can go ahead and try this, try now problem, pause the video, try it, and then you can verify your answer at the end, okay? So let's go ahead and do it. So let's go ahead and find the derivative. So f prime of x equals, now the derivative of inverse tangent function is 1 over 1 plus x squared. So 1 over 1 plus, but we don't have just x here. We have 3x squared already there. So we have to square that 3x squared. Now we have to use the chain rule and find the derivative of this inside function, which is 6x. Then plus the derivative of inverse sine function is 1 over square root of 1 minus x squared. So 1 over square root of 1 minus x squared, but we have 2x plus 1 in place of x. So that is squared times the derivative of this function, which is 2. Then the next one is minus the derivative of inverse cosine function is negative 1 over square root of 1 minus x squared. So with that negative, this becomes positive. So 1 over square root of 1 minus x squared. What do we have? Natural log of x. So we'll square this one. Then times the derivative of natural log of x, which is 1 over x. Now let's see how much we can simplify this. Okay, so f prime of x equals, so this is 6x over 1 plus 9x to the fourth. And then we have plus 2 over square root of, so now if we simplify this inside, we are going to get negative 4x squared minus 4x. Okay, you can go ahead and square that and then do the simplification. And here we get plus 1 over x square root of 1 minus natural log of square root of x. Okay, so we can factor out 4 from here out of the square root, and then we can cancel with 2. So let's do that one more step here. So f prime of x equals 6x over 1 plus 9x to the fourth plus 2. And then if I factor out 4 and take it out of the root, I get 2. And then I have negative x squared minus x. Okay, so plus 1 over x square root of 1 minus natural log squared of x. Now these two cancels out, so our final answer is f prime of x equals 6x over 1 plus 9x to the fourth plus 1 over square root of negative x squared minus x plus 1 over square root of 1 minus natural log squared x. Okay, so that is the final answer for this problem. And we'll just stop here for this video. I'll see you again in the next video.